So hi everyone, welcome to the next lecture of chemical engineering thermodynamics. Clear? So in the last class, if you remember, we started open system. I hope you remember this equation. We have developed the equation for what? Open system energy balance, right? So उसके basis पे हमने एक problem भी किया था, right? आपको याद होगा, right? So what was the equation for open system energy balance? आपको याद होगा, for example, right? That is d by dt of mass into internal energy of the control volume, right? So this is our first term, right? So this is our change in the internal energy of the system, right, or our open system, plus we used to represent it by del of, right, del of, what is the meaning of del? Del is the output minus inlet, right? So output minus input or outlet minus inlet, right, into mass flow rate multiplied by enthalpy plus kinetic energy plus potential energy, right, equal to your heat transfer plus work transfer. Clear? I hope you remember. So this is our energy balance equation, right? This is our energy balance equation for what, right? So this is our energy balance equation for open system, right? So if you remember, right, if you remember in the last class we have told this is a closed system. In closed system we used to write the energy balance as what? Du equal to del Q plus del W. That is whatever energy change is there inside the closed system is due to what? एक reason होता है heat transfer, एक reason होता है work transfer. Same thing, right? If it is an open system, क्या change रहेगा, right? आपका जो internal energy change or the major energy change inside an open system is due to what? Again, it is heat and work, and there is another two terms will be coming. That will be the energy coming in due to mass flow in and energy coming in due to mass flow out. That is inlet minus outlet will come. Clear? So that inlet minus outlet that will come in the right hand side, वो मैंने इस side लिया है, so that it will become what? We will represent it as outlet minus inlet. ठीक है? तो यहाँ तक तो डिस्कशन किया था हमने लास्ट क्लास पे, right? I hope you remember this as well. Clear? Right? I hope the board is visible, so there is some clarity problem. Now it is okay, I guess. Clear? So up to this we have discussed. ठीक है, सो मैंने बोला था लाइक लास्ट क्लास में भी, मतलब अकॉर्डिंग टू द क्वेश्चन गिवन टू यू, ठीक है, क्वेश्चन के हिसाब से यू हैव टू कैंसिल द टर्म्स गिवन हियर. मतलब इफ इट इज अ स्टेडी फ्लो डिवाइस यू कैन कैंसिल द डी बाई डी टी टर्म, राइट? अगर काइनेटिक एनर्जी पोटेंशियल एनर्जी जीरो दिया तो ये दोनों टर्म कैंसिल कर सकता है, राइट? इफ देयर इज नो हीट ट्रांसफर ये टर्म कैंसिल कर सकता है, देयर इज नो वर्क ट्रांसफर देन ये टर्म कैंसिल कर सकता है, देयर इज नो आउटलेट मींस आउटलेट टर्म कैंसिल कर सकता है. Clear? So this is the point, right? So according to the question you should be able to write the things or cancel the things, and you should be able to write the final equation. Clear? So next topic we are going to discuss is steady flow devices. Steady flow devices. Now the questions we have from the open system is already done. ठीक है, लास्ट क्लास में मैंने किया था, लेकिन फिर भी, राइट? सो सिंस दिस इज इन द सिलेबस, राइट, सिंस ओपन सिस्टम आर इन द सिलेबस एंड मैकेनिकल के लिए बहुत सारे क्वेश्चंस ऑलरेडी है, राइट, ओपन सिस्टम से, बट केमिकल वी हैव ओनली वन क्वेश्चन दैट ऑलरेडी हमने किया है लास्ट क्लास पे, राइट? But still we will do one or two problems from steady flow devices, right, to understand the things better, how to solve the question with this equation, right? So that is the only part. So steady flow devices, you are having lot of steady flow devices, okay? You are having lot of steady flow devices. So we are interested in solving the problems by using this open system equation. ठीक है? Solving the problem using this open system equation. So what is the meaning of steady flow devices? Sorry, right. So what is the meaning of steady flow devices? You know steady flow meaning is what? Your properties will not change with respect to time, right? So this is the meaning. So what we take as steady flow devices is, you can understand it like this, that is the operating conditions are not changing for a long period of time. Clear? So you can always remember it, that is the operating time does not change for a long period of time, right? So these are the type of devices whose operating time does not changing with respect to, operating time does not change for a long period of time, right? Or operating conditions does not change, not operating time, we will say operating conditions like all the property, yeah, like the pressure, temperature, or whatever thing, right? So all the operating conditions does not change with respect to time. Clear? So whatever conditions we are operating a one particular device, that is not changing for a long period of time, maybe 20 hours, maybe 1 day, right? Maybe 5 hours also you can take it, right? In that 5 hours we can say it is a steady flow device, right? I hope आपको समझ में आया, मतलब बहुत सारे टाइम तक if the operating conditions are not changing, you can call it as a steady flow device. ठीक है? So we have lot of steady flow devices in your example, right? So you have lot of devices are there, right? Now the first type of device, right? You have lot of devices are there, right? There are some devices given in your Cengel book the same way, right? So the first type of devices, nozzles and diffuser. Right, nozzles and diffusers. Now we are not interested to study what is the working procedure, right? How the construction is of a nozzle and diffuser. Nozzle and diffuser ka construction ya working, we are not interested. We are interested to solve the problem based on this equation in our thermodynamics. Clear? So what is the meaning of nozzle and what is the meaning of diffuser, you have to see. So simply how can you draw the diagram of nozzle and diffuser? So generally your nozzle is represented like this, that is, this is your velocity 1, this is your velocity 2, right? And diffuser will be the opposite of this. We can represent diffuser like this. This is velocity v1, this is velocity v2. Clear? So this is your diffuser and this is your nozzle. Clear? So we are interested in, right, we are not interested in the construction part or what is exactly this or the working procedure, we are not interested in. We are interested in if they give a nozzle or if they give a diffuser, how we are able to solve the problem, right, by using the first law equation, right? So what is this equation? This is the application of first law to an open system. Okay? So I hope you understood that. Clear? So nozzle and diffuser, so we can say nozzle is a device that increases the velocity, right? So if you want to understand the definition, nozzle is a device which increases the velocity at the expense of pressure, we can say, right? Nozzle is a device where the velocity is increased. Why the velocity is increased, right? Because the area is decreasing, so obviously the velocity will increase. Okay? So we will say in this case your V1 is very less compared to V2. V1 is very less compared to V2. You can say same way here. V1 is very higher than V2. Two conditions. Clear? So these two also you can understand, right? So these things you need to understand if you are calculating, right? If you are solving the question, you need to understand these things. Now, generally, right, generally whenever we solve the questions based on nozzle, right, what are the terms that are getting cancelled in this equation? It is a steady flow device, so the first term will be cancelled out, right? Steady flow device, the first term will be cancelled out. Generally we don't consider this potential energy, we don't consider. Normally we will take the heat transfer, right? Heat transfer is 0, work transfer is 0 for nozzle and diffuser. Right? So sometimes आपके question में ही दिया होगा, right? Heat transfer is negligibly small and work transfer is also small, right? And they will say potential energy is negligible. लेकिन आपको आपका जो kinetic energy change है, that you have to address, क्योंकि आपका velocity का increase हो रहा है, right? So that kinetic energy change you have to take into account for both cases, nozzle or diffuser. ठीक है? लेकिन बाकी सब cancel कर सकता है. And remember, sometimes आपको दिया होगा question पे, there is no need to consider heat transfer, no need to consider work transfer, right? If they haven't given, you can assume it as 0, right? In case of nozzle and diffuser, I am saying. ठीक है? So it is according to the question, right? मतलब according to the question say case also you have to select, right? You need to cancel the things. Clear? So I hope this part is done. ठीक है? So as given in your textbook also, right? As given in your textbook also, generally, right? Generally the heat transfer between the surrounding and the fluid flowing inside the diffuser is taken as 0. Clear? Heat transfer between the fluid and the surrounding is generally small, so we will take it as 0. And no work is involved during this process, so we will say that is also 0. And there is no potential energy change, so Gz is also 0. Clear? But kinetic energy change should be accounted. Now, right, how to solve this kind of questions, we will take it an example, right? We will do an example problem, then we will solve. Clear? So we will go to that example problem. Remember, in chemical we don't have any gate problem, so we will do a textbook problem, right? So textbook problem we will do, right? Clear? Now solve one question from 2020 because एक student ने मुझे पूछा था like sir how to solve this question, right? Since he asked, we will do this problem. Then we will go to the open system once again. ठीक है? GATE 2020 IIT Delhi. You can read the question. Consider 1 mole of an ideal gas in a closed system. It undergoes a change in state from L to N through 2 different non-isothermal processes. ठीक है? As shown in the PV diagram. PV is given. Process 1 is carried out in single step, Ln, whereas process 2 is carried out in 2 step, namely Lm and Mn. All the steps are reversible. ठीक है? All the steps are reversible. You can see the diagram close. Right? Now, the net heat flowing into the system for process 1 is Q1. Process 2 is Q2, the value of Q1 minus Q2. ठीक है? So they are asking what is the value of Q1 minus Q2. Clear? So I hope this question is done. Now we will go to the solution part. So you can see the diagram on the board. ठीक है? Now I will read the question once again. Consider 1 mole of an ideal gas. So it is an ideal gas and 1 mole वो भी दिया है. ठीक है? In a closed system undergoes a change in state from L to N. So L to N is your first process. ठीक है? Now second process is carried out in 2 step. First from L to M, then M to N. So this is your process 2. ठीक है? So first of all you have 2 processes. All the steps are reversible. That is also given in the question. All the steps are reversible. And net heat flowing into the system for process 1 is Q1. For the process 1 heat flow is Q1. For process 2 heat flow is Q2. How to calculate it? We'll see. First of all, क्या करना है? We'll apply the first law equation here. It's a closed system. ठीक है? So we can apply the heat first equation. So first of all, for the process 1, right? So I'm saying for process 1, right? For process 1, what will be my first law? Process 1 is L to N. So what will be my first law? Internal energy at state N minus internal energy at state L. Because UN is my internal energy at state N, that is my final state. UL is your internal energy at the initial state. UN minus UL, कोई problem नहीं है ना? It will be equal to what? Heat transferred during first process plus work transferred during first process. Simple. Now what about process 2? If I say process 2, what is the final state of process 2? Final state is again N because L, M, N. Final state is what? N. So what is your internal energy at the final state? N. Which is the internal energy at the initial state? Initial state for the process is L. क्योंकि 2 steps are there, लेकिन initial state क्या है? N. Sorry, initial state है L, final state है N. So it will be again UN minus UL. Will be equal to what? Heat transfer in second process plus work transfer in second process. ठीक है ना? तो आपका अगर इनिशियल स्टेट और फाइनल स्टेट सेम है तो आपका इंटरनल एनर्जी चेंज भी होगा सेम. वाई? क्योंकि आपका इंटरनल एनर्जी इज ए स्टेट फंक्शन. यहाँ तक तो ठीक है ना? सो व्हाट वी नीड टू कैलकुलेट? वी नीड टू कैलकुलेट Q1 माइनस Q2 है ना? राइट? वी नीड टू कैलकुलेट Q1 माइनस Q2. सो डू इट. टेक द equation 1 minus equation 2, right? You will get that 0 is equal to, right, 0 UN minus UL, right? Both are cancelled out, right? So this one minus this one, so you will be having what? Q1 minus Q2 plus W1 minus W2. So you need to calculate what? W1 minus W2, you can calculate it, right? That is, if I take this one, what is your Q1 minus Q2? Your Q1 minus Q2, that is the value you need to calculate, is equal to minus of W1 minus W2. ठीक है ना? No problem. Same. Now, how to calculate W1 and W2? W1 is for the first process. So for the first process, how can we represent your work done? Your work done for the first process is, your first process is Ln, The area under the PV diagram gives you the closed system work. So what is the area under Ln curve? Your Ln curve area is this area, this total area. Area under this curve. So this is your area under Ln curve. I hope that is visible in your video. Right, let me check. Yes, it is visible, right? The area under the curve Ln is this. Now, what about the work done in the second process? Second process is Lm and Mn. What is the area under that diagram? It will be this one, this triangular area. So what will be W1 minus W2? It will be the area of triangle LMN, right? When I say W1 minus W2, so that will be only this area under this triangle. So how can you find the area under that triangle? Easy. 1 by 2 into half into B into H. What is the base? Base is Lm. What is Lm? 0.03 minus 0.02. What is H? H is Mn. Mn is 100 kilopascal, that is 100 into 10 power 3. So 100, 0.1, that is 1000 divided by 2. What will be the answer? Answer will be 500 joule. Okay? So your Q1 minus Q2 is minus of 500 joule. So see the option. There is a 500 joule is there. Take it. And why we are getting minus 500? Because hamara sign convention is negative. Right? So our sign convention is negative for, if you remember isothermal processes. Right? If you remember isothermal processes, heat transfer is equal to minus of work. That's what we used to get. That's the only issue. Right? So don't be confused after seeing the sign convention. Lekin aap options dekh sakte hai. Right? You can see the option. That is minus 500 and 500 are not there. Dono nahi hoga aapke option pe. Right? Either 500 will be there, either minus 500 will be there. Because if you follow our sign convention, you may get minus 500. If you follow their sign convention, you may get 500. Right? So for that reason, they may not give you both answers. Right? They will not give you, they cannot give. Okay? So this is the meaning. So you can take the 500. I hope you don't have any other doubt. Okay, na? So next we will go to that our open system case. Right? ऐसे अगर आपको किसी भी क्वेश्चन में डाउट है तो you can ask me to solve it in the class, then I will do it in the class. ठीक है? So then now we'll go back to the open system diffuser problem. ठीक है? So then we will do that as well. Clear? So this is the question. I will read the question. Air at 10 degrees Celsius. Okay? Air at 10 degrees Celsius is there. Air at 10 degrees Celsius and 80 kilopascal enters into a diffuser of a jet engine, right, steadily with a velocity of 200 meter per second. So you can see 10 degrees Celsius and 80 kilopascal is the air inlet temperature and pressure, and it enters into a diffuser of a jet engine with a velocity steadily. You have to see steadily also, right, with a velocity of 200 meter per second, right. So velocity of the inlet is 200 meter per second. Inlet area of the diffuser is given 0.4 meter square. Inlet area of the diffuser is 0.4 meter square. Air leaves the diffuser at a velocity very low compared to inlet velocity. Air leaves the diffuser at a velocity very low compared to the inlet velocity. So what is the meaning of that statement, right? Air leaves the diffuser. I have just drawn the diagram of a diffuser. Aapko yaad hoga, right? So this is the diagram of a diffuser, the representation of a diffuser. Matlab this will be V1 and this will be V2. Right? What is the meaning of the last statement? Air leaves the diffuser at a velocity. मतलब आपका जो V2 है ना, V2 will be very 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 small compared to V1, and you can assume V2 as 0 here, right? So V2 is very very less than V1. So the meaning is what? V2 can approximately taken as 0 for solving the problem, right? So these things you need to understand. So the first question is what? Determine the mass flow rate of air, right? Determine the mass flow rate of air. Now determine the mass flow rate of air. What will be the equation for finding mass flow rate of air? Density into area into velocity. Calculate. Right? Now enthalpy of air leaving the diffuser. What will be the enthalpy of air leaving the diffuser is our second question. For that they have given enthalpy of air at 10 degrees Celsius 283.14 kilojoule per kg. and the molecular weight of air is also given. Right, so these are the given data, right? So that is enthalpy of air at 10 degrees Celsius. What is the meaning? It is the enthalpy at the inlet, because inlet is at 10 degrees Celsius and 80. So inlet enthalpy is given. H1 is already given to you. So you need to find what? H2. Enthalpy leaving the diffuser. So H2 you need to find it. Molecular weight of air is given as 29. So this is the question. So those who wanted to solve, pause the video, read the question once again and solve. Clear? That is, air at 10 degrees Celsius and 80 kilopascal enters into a diffuser of a jet engine steadily with a velocity of 200 meter per second. Inlet area of the diffuser is 0.4 meter square. Air leaves the diffuser at a very low velocity compared to the inlet velocity. Determine the mass flow rate of air is the first question. Enthalpy of air leaving the diffuser, that is the second question, and find both. Clear? Now, how to solve the first question? Determine the mass flow rate of air. Let me find it here itself, okay? Determine the mass flow rate of air. For a steady flow, what is the equation for mass flow rate? M dot is equal to density into area into velocity. What are the things given? Inlet area is 0.4. Right, so area is given 0.4 and velocity is 200. So only we need is what? Density. So density multiplied by area is 0.4 into 200. This will be the answer. Right, but how to calculate the density of air at the inlet? That is the only question. Right, how to calculate the density of air at the inlet? So you have the equation, right, for finding density of air. Right, how to find the density of air? Right, so density is equal to, can I write density is equal to Pm by RT multiplied by 0.4 into 200. All values are there. Pressure is at 80 kilopascal, right? Pressure is at 80 kilopascal. So substitute the values here, right? You will get the answer, right? That is pressure is 80 kilopascal. I am substituting as it is 80. Since I am substituting in kilopascal, there is no need to multiply by 10 power minus 3. If you remember the first class when I discussed about this equation, right? So molecular weight is 29. R is 8.314. Temperature is what? 10 degrees Celsius, that is 283. So this will be the density of air. Calculate that value. 80 into 29 divided by 8.314 into 283. That value is approximately 0.986. So density of air is 0.986. Multiply by 0.4 multiplied by 200. Your answer will be 78.92 kilogram per second. So this will be the value of mass flow rate. This is your first question. Clear? So this is your first question where they are asking the mass flow rate of air. Done. I hope everybody is getting the answer. First question, right? Density, area, velocity. Simple. Clear? So those who want to go back again, just pause the video, see the rewind the video and check how we are calculating it. Very simple. Remember, this unit will be what? It will be in kg per meter cube, because this is in kilopascal, right? So this is in your gram per gram mole or kg per kilomole, right? So this is in joule per mole Kelvin. So you will be getting kg per meter cube. I hope you understood. Clear? Now, can we go to the second question where you need to find the enthalpy? So for finding this, first thing is you need to write the energy balance equation, right? You need to write the energy balance equation. What is your energy balance equation? I hope you remember. D by dt of mass into internal energy of the control volume plus del is your outlet minus inlet, remind you, right? So del is your outlet minus inlet into mass flow rate into enthalpy plus kinetic energy plus potential energy equal to your heat transfer plus work transfer. Okay? So in this question they haven't given anything, that is they haven't given, it is a textbook question, right? So they are not supposed to give you the idea, right? So because they can write in the solution that is potential energy is neglected, heat transfer is neglected, work transfer is neglected, right? So as we already told, in case of a diffuser, there is no potential energy change, that you can cancel it out. There is no heat transfer from fluid to the surrounding. There is no work transfer also. So both values, all these values are cancelled. Now remember, in the question they have mentioned steadily, so d by dt term is also cancelled. Clear? So it's a very simple thing. Now elaborate this equation. This is outlet minus inlet, right? This is outlet minus inlet. So can I write it as m dot into, right? M dot into outlet is H2, inlet is H1 plus V2 square minus V1 square divided by 2 is equal to 0. Mass flow rate is constant value, right? It's a constant value. So it will go that side, that will be 0. Right? So I hope up to this is fine. Now find the enthalpy. Right? You need to find the enthalpy H2. What will be H2? H1 plus, right? H1 plus V1 square by 2 minus V2 square by 2. So what will be the equation? I will write it here itself. What is H1 here? Sorry, H2. You need to find H2, right? Enthalpy at the outlet. H2 will be equal to H1 plus V1 square minus V2 square divided by 2. लेकिन आपके क्वेश्चन में दिया हुआ है, राइट? आई होप यू रिमेंबर V1, ये हो गया आपका V2. V2 is very very small compared to V1, so V2 you can take it as 0. So what will be the value? So what will be the value of H2? H2 will be equal to, what is H1? H1 is 283.14 plus, what is V1? Whatever be the value of V1 square by 2, because V2 is 0. So this is your answer of H2. But you need to remember one thing. This unit is in kilojoule per kg. Right, this unit is in kilojoule per kg. V is 200. So 200 square divided by 2. This value will be coming in joule per kg because it is in SI unit. Clear? So either convert it into kilojoule per kg, this one, and add, and you will get the value of H2. Otherwise, convert this into joule per kg and add, and finally get it back to kilojoule per kg. Right? So understood the difference between these things, and give me the answer. What will be H2? Your answer will be almost 303.180 joule per kg. Right? Convert this into your joule per kg, add with that, you will get this answer. So it will be 303.180 kilojoule per kg. I think that is the answer. 303. It is not 18, it is 140. Clear? I hope all of you are getting the answer. Clear? So this is a question given in your essential book. Clear? It's a solved example, right? So those who want to go back and check the book, you can do it, right? These kind of questions they haven't asked so far in chemical, right? But still some test series they have asked this. Very simple to solve, okay? That is, if you cancel the terms in the first law equation, it's very simple to find the answer, right? After seeing the question, you may think, okay, it is somewhat tough, but it's very simple, right? It's very simple to solve. So we'll go to the next problem, okay? We'll go to the next problem. So this is your next question. So this is from another steady flow device, compressor, right? So this is another question from another steady flow device. So this is your compressor. Now you can see here steady flow device, compressor. So here the compressor is an open system, right? It's an open system steady flow device, right? So you can see air at 100 kilopascal. I am reading the question. Air at 100 kilopascal and 280 Kelvin. So mark it all the way, right? So air at 100 kilopascal and 280 Kelvin is compressed steadily, right? Compressed steadily. That is steadily it is compressed into 600 kilopascal and 400 Kelvin. Clear? So obviously you can see here inlet temperature is 280 and pressure is 100. It is compressed to what? 600 is a higher pressure and higher temperature. Clear? So now they have given the mass flow rate of air is 0.02 kg per second. So what is the meaning of mass flow rate? Right? There is something is coming into the system and something will be going out. So that's why whenever there is a mass flow rate is given, you have to understand, okay, it is an open system. ठीक है, तो ऐसे समझना होगा आपको, मतलब ये ओपन सिस्टम है, क्लोज सिस्टम है, कैसे समझते हैं, राइट? यू हैव टू अंडरस्टैंड इट फ्रॉम द फ्लो रेट गिवन, राइट? अगर क्लोज सिस्टम है तो देयर विल बी नो फ्लो रेट, ठीक है, सब कुछ क्लोज होगा, राइट? देयर इज नो मास ट्रांसफर, राइट? सिंस इट इज ओपन सिस्टम, आपके पास ये वैल्यू दिया है, राइट? सो 0.02. नाउ एंड देयर इज अ हीट लॉस ऑफ 16 किलो जूल पर केजी ड्यूरिंग द प्रोसेस, मतलब आपके कंप्रेशन के टाइम पे देयर इज अ हीट लॉस ऑफ 16 किलो जूल पर केजी, ठीक है? सो देयर इज अ हीट लॉस ऑफ 16 जूल पर केजी, दैट इज व्हेन यू आर कंप्रेसिंग समथिंग, you are releasing some heat to outside as well. Clear? Now assuming changes in kinetic energy and potential energy is negligible, मतलब changes in kinetic energy potential energy दोनों negligible दिया है. Determine the necessary power input or work input, right? So determine the necessary work input to the compressor. तो मैंने already आपको compressor के बारे में बताया था, that is we are giving some work input to compress something, ठीक है? We are giving some work input to compress something. So when it is compressing, we may release some heat to outside. Clear? So if we release some heat to outside, what is the meaning? It is not an adiabatic compression, right? It is not an adiabatic compression. There is some heat release. Clear? So it can be an isothermal compression, but you can see here the temperature is changed from 280 to 400, so it is not an isothermal compression as well, right? So it can be a polytropic process, right? It's not adiabatic, it is not isothermal. Clear? I hope you understood. Now what should be the work input, right? यही calculate करना है हमें, right? What should be the work input? Now remember, right? Now remember, you can easily solve this question based on our equations in closed system, right? If the system was closed system. Clear? Because P1, T1, P2, T2, everything is given, and if you have that relation PV power something is equal to constant, you can solve the question. Clear? But the problem here is what? Right? It is an open system. So you have to use what? Open system energy balance. हम closed system balance apply नहीं कर सकते. Right? Whatever equations we have developed in the closed system, we cannot use it here because there is a mass flow in. ठीक है? So whenever there is a mass flow in, you cannot use the closed system equation. Clear? यहाँ तक तो समझ में आ गया ना? Right? So next we will see how to solve this particular part. So read the question once again. Clear? Air at 100 kilopascal and 280 Kelvin is compressed steadily into 600 kilopascal and 400 Kelvin. Mass flow rate of air is given, and there is a heat loss of 16 kilojoule per kg. Assuming kinetic energy changes and potential energy changes negligible, determine the work input to the compressor. Inlet enthalpy is given to 83.13 kilojoule per kg, and outlet enthalpy is also given. Now how we are going to solve this question? That's the problem, right? How are we going to solve this question? So now let us see how we are going to solve this. What will be the first step, right? What will be our first step? Very simple. First step will be, obviously we need to write the balance for our open system. How to write the balance? D by dt. So always try to write this equation by yourself, otherwise आप लोगों को याद नहीं होगा, right? So you have to write it, right? D by dt of mass into internal energy of the control volume plus, ठीक है? What is the meaning of del? Del is your outlet minus inlet, right? Outlet minus inlet into mass flow rate. H is your enthalpy. V square by 2 is your kinetic energy. G set is your potential energy, equal to heat transfer plus work transfer. ठीक है? यहाँ तक तो ठीक है ना? Everything is done. Now what is this term? H plus V square by 2 plus G set. This term is your energy of the flowing fluid. मतलब, right? Total energy of the flowing fluid is always represented by these three terms. Total energy of the flowing fluid, that is H plus V square by 2 plus G set. Clear? So I hope you understood. Now let us see from the question, right? From the question given to you, right? What are the things that can be cancelled in this equation, right? क्या क्या terms cancel कर सकते हैं यहाँ पे? First thing, it is a compression process. It is a steady flow device. So first term is steadily is given. So steady flow means this term can be cancelled out. Simple, right? Steady flow, first term is cancelled out. Now you have an inlet, you have an outlet, so del will stay, right? Outlet minus inlet will be there. लेकिन kinetic energy change and potential energy change is negligible. So दोनों cancel कर सकते हैं ना, simple. Kinetic energy change v square by 2, potential energy change g set, दोनों cancel कर सकते हैं. And heat loss दिया है आपको, work आपको calculate करना है. So write the remaining equation. It is outlet minus inlet, okay? It's outlet minus inlet. So आपका जो mass flow rate multiplied by enthalpy outlet minus enthalpy inlet will be equal to, what is heat loss? Heat loss is minus 16. It is minus 16 kilojoule per kg. Why there is a minus sign? Because it is heat loss, yeah, right? So it's a heat loss, so it should be minus 16. And you need to find what? Work input. And remember, work input का unit क्या होना चाहिए? You have to get the answer in kilowatts, or your unit should be in kilojoule per second. Right? Your unit should be in kilojoule per second. This is the equation. Mass flow rate into H2 minus H1, right? H2 minus H1 because outlet minus inlet. Kinetic energy change is 0, potential energy change is 0. Heat loss is minus 16 because it is a heat loss. If it is a heat gain means plus 16, no problem. 16 kilojoule per kg, like this. Clear? So this is the basic thing you need to write from the question. I hope you understood. यहाँ तक तो ठीक है ना? I hope it's clear. Done? Now the problem is what? Problem is understanding the unit. ठीक है, आपको आंसर चाहिए किलो जूल पर सेकेंड पे, राइट? योर आंसर शुड बी इन किलो जूल पर सेकेंड, राइट? नाउ वी विल सी मास फ्लो रेट. व्हाट इज द वैल्यू ऑफ मास फ्लो रेट? 0.02 kg per second multiplied by H2 minus H1 will be what? H2 is 400.98 minus H1 is 283.13. These values are in what? These values are in kilojoule per kg. So your left hand side, right? Your left hand side, what will be the unit of this term? It will be kilojoule per second. No problem, right? This side is kilojoule per second. You will get the answer in kilojoule per second. Now we will see right hand side. Right hand side we have minus 16 in kilojoule per kg plus you need the answer in work input in kilojoule per second. Clear? So kilojoule per second, work input you need in kilojoule per second. So you need to convert this kilojoule per kg into what? Kilojoule per second. Then only add कर सकते हैं ना. Every term should have the same unit. Then only we can add it. ठीक है? ये तो किलोजूल पर सेकंड में चाहिए आपको, ये भी किलोजूल पर सेकंड पे आ रहा है, राइट? सो दिस ऑल्सो शुड बी कन्वर्टेड, राइट? सो वी हैव अ हीट लॉस ऑफ 16 kilojoule when we have 1 kg of mass, right? When you have 1 kg per second mass flow, or when we have a mass of 1 kg, for a mass of 1 kg you have a heat loss of 16 kilojoule. Now how much is your mass flow rate? So you have to multiply this term, right? You have to multiply this term also with 0.02 kg per second. So kg cancel out, so this will also come in kilojoule per second plus work input. Abhi calculate kar lo, right? 0.02 into this and find the work input and tell me the answer. What will be the answer coming in kilojoule per second? Clear? .02 into this and find the answer for work input. I need the answer in kilojoule per second. I think the answer is 2.737 kilowatt. This is the way we will be solving questions in first law open system. Clear? ठीक है ना यहाँ तक? I hope you understood. Right? Once again, right? So we have first written what, right? We have first written your general equation in first law, that is d by dt of mass into internal energy of control volume plus outlet minus inlet of mass flow rate into enthalpy plus kinetic energy plus potential energy equal to heat transfer plus work transfer. ठीक है, तो यहाँ पे आप देख सकते हैं फर्स्ट ऑफ ऑल स्टेडी फ्लो, दिस कैंसल आउट, काइनेटिक एनर्जी पोटेंशियल एनर्जी नेग्लिजिबल, सो ये दोनों कैंसल आउट. नाउ व्हाट इज रिमेनिंग, राइट? रिमेनिंग थिंग इज, right, it's very simple to write the remaining things, that is mass flow rate, it is outlet minus inlet, so mass flow rate into H2 minus H1. Why? Because del meaning is what? Outlet minus inlet, right? So outlet enthalpy minus inlet enthalpy, steady flow, mass flow rate is constant, equal to what? Your heat transfer plus work transfer. लेफ्ट हैंड साइड का यूनिट आएगा आपका किलो जूल पर सेकेंड, तो यहाँ पे भी किलो जूल पर सेकेंड पे होना चाहिए, यहाँ पे भी किलो जूल पर सेकेंड पे होना चाहिए, राइट? सो ओनली प्रॉब्लम इज कन्वर्ट द हीट ट्रांसफर इन टर्म्स ऑफ किलो जूल पर सेकेंड, आपको आंसर आ जाएगा. क्लियर? सो दिस इज आवर प्रॉब्लम बेस्ड ऑन व्हाट? योर ओपन सिस्टम. डन. सो we'll move to the next device, next steady flow device, that is your throttling valve or throttling devices, right? So throttling devices or throttling valve, right? So regarding this application we will study in your refrigerator chapter, right? That is in our second law of thermodynamics. We have a use of what? This throttling devices, right? So in that we will learn more about its application, right? Now we are interested in solving the problems based on what? The same thing. मतलब अभी हमने कंप्रेसर और आपका जो नोजल एंड डिफ्यूजर यूज करके, मतलब फर्स्ट लॉ ऑफ थर्मोडायनामिक्स यूज करके we have solved problems. Same way we are interested to study throttling devices with respect to the first law, right? So we are applying the first law of thermodynamics into this throttling device, right? Clear? I hope you understood. So it is a flow restricting device. You can write if you want. It's a flow restricting device. Flow restricting device that causes significant pressure drop, right? It is a flow restricting device that causes significant pressure drop. Example for this type of throttling device is your small capillary tube, right? It's a small capillary tube, meaning what? It's a small capillary tube, that is when a flow enters into the small capillary tube, what happens, right? You have this much pressure, right? This much fluid pressure is coming in. When it is entering into the small capillary tube, there will be a significant pressure drop. Clear? There will be a significant pressure drop. So this pressure drop accompanies with what? Temperature drop also, right? That is, suddenly if the pressure is decreased, right? So you will have what? You will have also the temperature drop. So due to this particular speciality, we will be using this capillary tube or throttling devices in our refrigeration, right? Because we need the temperature to go down. Clear? So this is the meaning. So remember this. So our capillary tube or your throttling devices are the devices for restricting the flow, and it causes a significant pressure drop, right? It causes a significant pressure drop. Now, so once again, if you want to write, you can write, right, this thing, and the pressure drop is often accompanied with what? A temperature drop, right? So the pressure drop is often accompanied by a temperature drop. For this reason, right, for this reason, throttling devices are commonly used in refrigerator or air conditioning devices. That also you can write, right? So the pressure drop accompanies with the temperature change, right? For this reason, this is commonly used in what? Your refrigeration examples, sorry, refrigeration devices, right? Or AC, right? Air conditioning devices. Now we are not interested in the working and how it is going. We are interested to apply this first law equation, right? So what is the first law equation? D by dt into mass into internal energy of the control volume plus outlet minus inlet of, del is outlet minus inlet, ठीक है? Mass flow rate into enthalpy plus kinetic energy plus potential energy equal to heat transfer plus work transfer. Now, right, no cell के केस में हमने assume किया था there is no heat transfer, work transfer. Same thing. What are the assumptions we take in throttling devices? वो भी check करते हैं first of all. General assumption is the throttling devices are very small devices and we will consider it as adiabatic. Right, it's an adiabatic. Normally we will consider it as adiabatic devices, so Q will be equal to 0, and generally we will consider the work transfer is also 0. And also it's a steady flow device, so obviously the first term will also be cancelled out. And generally we don't consider the kinetic energy change and potential energy change. Right, so this is the common assumption. Right, this is the common assumption we make in thermodynamics. Clear? Now from this we can say what? Only enthalpy term is there, so we can say your outlet enthalpy will be approximately equal to inlet enthalpy in case of what? Throttling devices. Can you understand that? Right, that is all the other terms are cancelled out. So since this ink is not clear in the board, H2 is approximately equal to H1 because all the terms are cancelled out, right? So due to this reason we will call throttling devices isenthalpic devices. Meaning is what? Enthalpy is same here. Isothermal means temperature is same way. Isenthalpic, the meaning is enthalpy is same for both cases. Is it fine? Right, isenthalpic devices. Clear? Now, right now, up to this is fine. Now you can see the major change. Clear? So let me see, I hope the board is visible now. Right, yes, right. So we already told it is an isenthalpic device, right, and it is an adiabatic device we told because we are taking Q is equal to 0. Now remember, for ideal gases के लिए क्या change हो सकता है? Right, for ideal gases what is the change? For ideal gases you know, हमने ये closed system में मतलब ideal gases के लिए हमने ये पढ़ा था, your enthalpy is a function of temperature only. Your enthalpy is a function of only temperature. मतलब अगर आपका enthalpy temperature का ही function होगा, right? So both enthalpies are same. Then we can say what? Throttling is what is the meaning? मतलब आपका enthalpy is a function of only temperature, right? लेकिन after throttling and before throttling दोनों enthalpy same है. So meaning is what? Throttling is isothermal for ideal gases. Right? If it is not ideal, you can take it as adiabatic because it is an adiabatic case, no problem. But right, for ideal gases, throttling is isothermal because H is equal to this. Right? H is a function of temperature only. I hope you understood. Clear? So remember this as well. So for throttling for ideal gases, right? Throttling for ideal gases will be isothermal. Clear? So this also you have to remember. So these are the major steady flow devices we have in our syllabus. Even though we don't have much questions, right? So far in GATE we don't have much question from these topics. That's why I have solved the textbook questions here, right? ठीक है, because आपको आना मतलब major questions एक question है, right? So that we have already solved in the last class. That is open system, right? So there was an open system and gas was filling against vacuum. वो तो already हमने किया है. लेकिन बाकी questions कैसे solve करेंगे, right? So if you are seeing questions from mechanical engineering, otherwise आपको solve करना आना चाहिए. That's the only point. ठीक है? This is sufficient for chemical engineer. That's what I feel. क्योंकि हमारा questions बहुत कम आया है इसी topic से, right? So we will see. There is one gate question that we will solve also. ठीक है? I hope up to this is fine. So this is a GATE 2012 question. In a throttling process, the pressure of an ideal gas reduces by 50%. Clear? The pressure of an ideal gas reduces by 50%. If Cp and Cv are the heat capacities at constant pressure and constant volume, right? If Cp and Cv are the heat capacities at constant pressure and constant volume, gamma is Cp by Cv, the specific volume will change by a factor of, right? The specific volume will change by a factor of. That is the question. Clear? I hope you understood the question. The options I will write it on the board, right? So then we will solve. Once again I will read the question. In the throttling process, the pressure of an ideal gas reduces by 50% if Cp and Cv are the heat capacities at constant pressure and constant volume. The specific volume will change by a factor of. Options I will write it on the board. Clear? Right, so I hope you have seen the question. So let me write the options on the board. So throttling given, right? So once again I will read the question. In throttling process, the pressure of an ideal gas reduces by 50%. Pressure of an ideal gas reduces by 50%. And they have given gamma is Cp by Cv. Now, the specific volume will change by a factor of. Option A is specific volume will change by a factor of 2. Specific volume will change by a factor of 2 power 1 by gamma. 2 power 1 by gamma. And C, 2 power gamma minus 1 by gamma. Option D, 0.5. If the pressure of an ideal gas reduces by 50%, what factor your specific volume will change? This is the question. Clear? Now, it is a throttling, right? It's a throttling. If you take throttling as adiabatic, you will get a different answer. But you have to remember, right? The given question, right? Given question is about throttling of ideal gases. So, for ideal gases, throttling is, right? For ideal gases, throttling is isothermal. Remember that, right? So, for ideal gases, throttling is isothermal. So, what is the equation for isothermal? P1V1 equal to P2V2. That is isothermal, meaning is what? PV is equal to constant. Clear? Otherwise, how can you write this? Right? How can you write this? The same equation, how can you write this? Either आप ऐसे लिख सकते हैं, throttling is isothermal, ठीक है? Throttling is isothermal. So for an isothermal process, हम लिख सकते हैं PV is equal to constant, right? PV constant है तो P1V1 is equal to P2V2. You can write like this, ऐसे लिख सकते हैं. नहीं तो, you know for throttling, H1 is equal to H2. What is H1? H1 is U1 plus P1V1 is equal to H2 is U2 plus P2V2. ठीक है, लेकिन आइडियल गैस के लिए, राइट, सो यू नो आइडियल गैस इट इज आइसोथर्मल, सो इंटरनल एनर्जी दोनों सेम होगा, राइट, अगर टेम्परेचर चेंज नहीं हो रहा है तो आइडियल गैस के लिए P1V1 is equal to P2V2. So they have given pressure of an ideal gas reduces by 50%. So what will be the meaning? P2 by P1 is equal to V1 by V2. So what is P2 by P1? Reduces by 50%, meaning is 1 by 2 is equal to V1 by V2. अभी you should not tick 0.5, that is the only problem. आपने देखा है V1 by V2 is 1 by 2, so D is not your answer क्योंकि they are asking specific volume will change by a factor of, right, change by a factor of, so you need to find the relation between V2 and V1. Clear? So V2 is equal to 2V1, so V1 is changing by a factor of 2, right, so specific volume will change by a factor of 2. Clear? This is the meaning, right? So always remember, if your V2 is 10, it is 2 into 5, so V1 is 5, so 5 is changing by a factor of 2, so that's why 2 is the answer. Clear? So you should not write V1 by V2 and it is equal to 1 by 2, and you should not write 1 by 2.5 because to confuse you, वो 0.5 भी दिया हुआ है question पे, ठीक है? So you have to write it correctly, right? So the correct answer will be 2. ठीक है? So this is the only question they have asked from open system, we can say, right? Again based on that, ठीक है? लेकिन if you remember throttling is isothermal also, ये solve हो सकता है, right? So this is the only question we have in the last 20 years, we can say. Clear? So we have solved all the questions in open system, closed system, etc. Right? So that is the end of our first chapter. Right? First law of thermodynamics is over. Clear? So in the last class, one student asked me, after the class he asked me this question, that is this 2006, this our 2006 question paper, it's GATE Academy booklet, you can see. So it's 2006 IIT Kharagpur. So they are asking the question, molar density of water vapor at the normal boiling point of water is 33. Okay, molar density of water vapor at the normal boiling point of water is 33. Compressibility factor under these conditions is close to which of the following? R is given. ठीक है, so calculate the value. ठीक है, so one student has asked doubt in this, that's why we are solving here, right? So otherwise our topic is over, right? That's our first law of thermodynamics application in the closed system and open system is over. Clear? Now we'll solve this question. Clear? So we'll read the question and then we will solve it, right? That is, what is the question? The molar density of water vapor at the normal boiling point of water is, right? That is normal boiling point of water, the molar density is given 33 mole per meter cube. 33 mole per meter cube. So what is the normal boiling point of water? 1 atm and temperature is 100 degrees Celsius. Right, so this is the normal boiling point of water. Clear? So they are asking to find the answer in compressibility factor, right, close to the options given. What is the equation for compressibility factor? Compressibility factor is what? PV divided by N into R into T. Clear? So what is molar density? Mole per meter cube. So N is in mole, V is in meter cube. So N by V value is given, right? N by V value is already given to you. So solve the remaining, right? Then find the answer. Simple, right? Clear? I hope you remember this. So what is the pressure? Pressure is normal boiling point is given in 1 atm, but you have to substitute in the SI unit. What is that? 101,325 is the value in Newton per meter square. Clear? Now, number of moles is in number of moles divided by V is given as what? 33 mole per meter cube, right? So it is 33 here. N by V is this value. Okay? So those who are having confusion, molar density N by V is given, right? Kg per meter cube is your mass density, right? Density unit is what? Kg per meter cube. So this is your mass density. ये आपने आपका fluid mechanics में किया होगा, right? Mass density. So molar density means N by V, mole per meter cube. Clear? R is what? What is the value of R? 8.314. Temperature is what? Temperature is 373 Kelvin. So अब अगर unit check करना तो you can check it, right? Mole per meter cube multiplied by what is 8.314 unit? Joule per mole Kelvin, right? Joule per mole Kelvin. Now multiplied by Kelvin. Unit check kar lo aap, right? If you want to check the unit, mole cancelled out, Kelvin cancelled out, right? And there is a meter cube, and here you have joule is Newton meter. Clear? So meter square cancelled out here as well. So Newton is cancelled out. Right? No unit for compressibility factor. Right? Now it is correct. So if you do this, you will get approximately 1. Clear? You will be getting the answer approximately equal to 1. So the options are 0.75, 1, 1.25 and 1.5. You will get the answer 1. Clear? I hope everybody is getting. So I hope that question is also done. Clear? So that completes our first chapter, we can say. For not first chapter, it includes almost our 75% of Thermo 1 is over for chemical engineering syllabus. Clear? So if you remember, what are the things I have taught? First of all, हमने first discuss किया था this thing, du is equal to del q plus del w. So this is the first basic thing we have studied. तो ये था हमारा closed system balance. ठीक है? तो closed system balance के बाद हमने open system balance लिया. What is the open system balance? d by dt of mass into internal energy of the control volume plus del is what? Del is your outlet minus inlet, that is mass flow rate into enthalpy plus kinetic energy plus potential energy equal to heat plus work. ठीक है. So this was the equation for what? Our open system first law. This is your equation for closed system. ठीक है. So based on this we have covered all the questions in thermodynamics so far, right? So it is our 10th lecture, for maybe 11th lecture, right? So that completed our thermo 1, almost 75%. Now what we have left is only your second law of thermodynamics is comparatively easy compared to your first law, right? So because first law में हमें बहुत सारे equations याद करना है, right? So there are a lot of equation, derivation, बहुत कुछ है. But in second law we don't have that much equation to remember. ठीक है? If you understand the logic, you can easily write the equation, you can easily solve the question. Second law is very simple, right? We have some refrigerator, we have some heat pump, we have some this thing, heat engine. That's all, right? In second law, and you have a basic explanation of entropy. ठीक है. सो बेसिक एक्सप्लेनेशन ऑफ एंट्रोपी. एंट्रोपी के ऊपर हमारा क्वेश्चंस भी बहुत बेसिक्स आया है केमिकल में, राइट? सो दैट्स व्हाट वी आर सेइंग. सो दैट आल्सो वी विल कवर. क्लियर? सो देन वी विल मूव टू व्हाट आवर thermo 2, right? So this is the point. So go through all the questions, right? Go through all the questions that we have done. So once the thermo 1 is completed, right? So we have the topic wise test series, test in our Gate Academy test series newly launched. ठीक है. अब वो आप वो भी लिख सकते हैं, right? After the completion of thermo 1. Clear? So these are the things we need to note. So thermo 1, almost this thing is over. That is basic pure substances part is done, right? And first law is done, and first law for both closed and open is done. Clear? And remember once again, your weightage for thermodynamics 1 is maximum 2 to 4. Maximum is 4 marks. ठीक है. So you have to concentrate more on thermo 2 in chemical engineering thermodynamics, right? So this is for 2 to 4. If you study this very well, that's my guarantee, right? So if you study whatever we have covered so far, these 11 lectures, we have solved all the questions here. You will know all the concept, right? You may not be able to solve the mechanical engineering problems. That I cannot guarantee, but what I can guarantee is you can solve all the questions in chemical engineering. Right? Because we didn't study on the unwanted things in terms of gate, I am saying, right? You can learn everything, right? For thermodynamics, that's okay, right? But for chemical engineering gate, what are the important things? That's what I have covered. ठीक है. So that is very much important, right? So only in gate point of view you have to concentrate, right? If you are preparing only for gate, that's my option. Clear? So for mechanical you have other lectures, like for mechanical engineering students they have other thermodynamics topics as well, right? So they have different other topics, or they have more detailing. But as far as chemical is concerned, we need only this. But for thermo 2 we have more interest. Clear? हमें बहुत सारा question solve करना है. We need to understand lot of concept, right? So that we will go later. Clear? So tomorrow from next class, right, we will be starting what? Our second law of thermodynamics. Clear? That's all. Thank you very much.